Okay, so here's just one more example of some ways you might be asked a question about confidence intervals. But like if you look at, say, this, and this is from the 2015 test, if you look at this free response question, you'll notice this doesn't just say construct and interpret. Instead, they want you to look at different details of the confidence intervals. So to increase business, the owner of a restaurant is running a promotion in which customers' bills randomly selected to receive a discount. When a customer's bill is printed, a program in the cash register randomly determines whether the customer will receive a discount on the bill. The program was written to generate a discount with a probability of 0.2, that is 20% are supposed to work. So that's probably going to be important that we're kind of like, is P equal to 0.2, okay? And however, the homeowner is concerned that it's not working. Okay, so I'm sorry. However, the owner, I said homeowner. I think I was like smashing those words together. Okay, so they randomly select a sample and found P hat to equal 0.15. Okay, so 15% of the sample received the discounts. And they calculated the margin of error to be 0.06, so 6%. So in this case, so they already did the margin of error. Okay, so consider the interval 0.15 plus or minus 0.06. All right, so for part A, we're just trying to decide, let's look at this point P equals 0.2 and decide, does our interval suggest P is equal to 0.2? Does it suggest P is not equal to 0.2? What does it suggest? Okay. So the first thing I would do is actually do 0.15 plus or minus 0.06. So if I do 0.15 minus 0.06, I get 0.09. And if I do 0.15 plus 0.06, I get 0.21. Okay. So we have this, and so the question becomes for part A, part one, do we have evidence that the program is not working? In other words, if the program is not working, can we say P not equal to 0.2? And the answer to that is, so what our interval suggests is that the percent of discounts, or percent of the bills that get discounts, is somewhere between 9% and 21%, okay? And 20, this 0.2, is inside the interval, meaning it is a possible value for P, okay? So we do not have convincing evidence because 0.2 is in the interval. So the program, I'll get this out of the way. Could be generating 20% of bills to get the discount. Okay. Now, when we look at part two is saying, can we say that it is working with P equals 0.2? We can't say that either, okay? Because there are other values besides 0.2 in the interval. So in other words, this interval doesn't tell us if the program is working or not working, because while 0.2 is in the interval, it's not the only value that's inside that interval. Okay? All right. So this next one, part B is a definitely the hard crux of this question, designed to make this a little bit more difficult here. So a second random sample of bills that was 4 times the original sample. So we now have 4n is our sample size. Four times that original sample, okay, where n is the original sample size, okay? And we also have a p-hat of 0.15. So the p-hat didn't change. We have 4 times the larger sample, okay? Determine the value of the margin of error used if I use the same confidence level as the original interval. So this is a really challenging kind of thing to think through, because there's so many unknowns. We had for instance, we don't know if our original confidence level was 95%, 99%. So we know we have a Z star, but we don't know what that Z star is, okay? But so let's go ahead and pretend that the original interval, this one, with this margin of error, okay, was 95%. Then the Z star would have been 1.96, okay? And the Z star would have stayed 1.96 for this new interval that we're creating, okay? So if I look at that old interval, and I assume this 95% confidence, okay? My margin of error would have been 1.96 times the square root of 0.15 times 0.85 over some sample size that we don't know. And what we know about this new interval. So for the old interval, we knew that p-hat was 0.15. So let's talk about what we know about the new interval. The margin of error, well, the Z star would be 1.96 times. My new p-hat was also 0.15. And the last thing I know is that my sample size is 4 times the original sample size. And so really, the fact that the new p-hat stayed 0.15, and that I'm using the same Z star, and even if it wasn't 95%, the fact that it's the same confidence level for both means that whatever this Z star component is, whatever it is, it would be the same Z star because it's the same confidence level. And I know my original margin of error is 0.06. Well, so now when I look at really that 4 in the denominator here, this 4n, the fact that I multiplied the sample size by 4, is the only thing that's different between our two margins. And I'm going to point out that 4 is underneath the square root sign, okay? So in reality, that 4 is equivalent to a square root of 1/4, okay? Which is half. So I could rewrite this as 1/2 of, I keep doing that. So I could take that half out front. And now I already know that the answer to this, since they're the same, is 0.03, is 0.06. So I'm doing half of 0.06, which is equivalent to 0.03. So my new margin of error is 3%. In other words, if I multiply my sample size by 4, my margin of error is going to shrink by the square root of 4. Okay, so divided by the square. So now, this is another good example for me to point it out. A lot of students did not know how to do this question when this was given on the AP exam. Okay, and they skipped part B and then they tried to answer part C. Okay, this would be an example of a time where if you didn't know how to do it, you could at least make up a margin of error. You won't get credit for part B. But now, for part C, now we're going to do plus or minus the same interval, only we're going to cut that margin of error in half. So if you made something up for part B or you got part B wrong, but you still answered part C correctly, you got full credit. But because this is based on your margin in part B, if you didn't have an answer for part B, you weren't able to get credit for part C. So it's okay to make up an answer if you don't know how to do something, okay? And now we can say 0.2 is not in the interval. From this, based off of this new larger sample, 0.2 is not in the interval. So we can say that the program is not working. Okay, so this brings up one less thing about sample size. The relationship between, say, sample size and margin of error. As we change our sample size, by a factor of, and I'm just going to use A. Okay, so for instance, up here, if I multiplied my sample size by 4, okay, then that factor would be 4. But so if I multiplied my sample size by 9, then I'm talking about a factor of 9, okay? The margin will be inversely changed by a factor of the square root of A. And the reason I say inversely, so if I take 4 times my sample size, I get 1/2 the margin of error, because as the sample size increases, the margin of error decreases. If I take 1/9 of my sample size, I will have 3 times the margin of error, because my sample size is smaller. My margin of error is going to increase by a square root of that factor. So hopefully that kind of makes some sense to you. Lastly, just one more example of we want to estimate with 95% confidence to be within less than 0.1. Okay, so 95% confidence means my z-star is 1.96. We kind of did these last week, just one quick reminder that we use 0.5 if we don't know a p-hat. And so this part is the margin of error, the critical value times the standard error of p-hat, okay? And then we're working this equation such that we end up with the answer to it's less than 0.01. Okay, from here, this is just doing some basic algebra. I'm going to divide both sides by 1.96. And I have the square root of 0.25 over n is less than 0.005. Square both sides. I'm not clearing my calculator as I do this. So now I have 0.25 over n is less than 2.6 times 10 to the negative fifth. Multiply both sides by n. And then I'm going to divide 0.25 by 2.6 times 10 to the negative fifth. Again, not clearing my calculator, and I get 9604 has to be less than n, or n has to be greater than 9604, 9605. Okay. Chances are that 9604 is a rounded decimal of some kind. It's the only reason I did that. If you put 9604 you'd probably get full credit as well. But chances are it's 9604 point, even if it's 0.000001, we would round it up. So hopefully this is just some last reminders for you guys, and I'll see you guys soon.